Hey everybody, thanks for watching. So today we're going to be answering some questions that I've been getting regarding measuring devices. So, there's a plethora of devices out there in all price range for your calipers and your micrometers. And sometimes it's really hard to know, is it worth it? The import items that we get are getting better and better. They honestly are. Things we used to buy online that came from China were generally considered junk. And now they actually are making some okay devices. I wouldn't say that they're great, but they're okay. Even some of the major manufacturers of high precision devices are, of course, having them made in China to their specification. People immediately tend to dismiss items made in China, and for a large amount of tools and measuring devices and pieces and etc., yeah, it's sketchy unless you know the manufacturer, the company, or they have true certifications, not just some piece of paper in the box. Okay, but we want to take a look at cheap measuring devices. Is there a place in the machine shop for cheap measuring devices? And if so, what is that place? So let's go over to the bench and we'll take a look at an assortment of devices and discuss the variances. And then please comment down below, and I'd like to hear your thoughts as to what you think on cheap devices in the machine shop. Okay, here we go with our assortment of measuring devices here. So you see we've got a couple different calipers and a couple different micrometers here that we're going to take a look at. So I've got my higher end devices, my Mitutoyo, and quite honestly I don't remember which brand this one is. It's a relatively inexpensive one, but it's turned out to be very good. This is a Home Depot, I think Home Depot, and I can't remember where that even came from. But just an array to go over what we're talking about here. So the entire point of this discussion is about do cheap measuring devices have a place in the shop? And I'm going to say yes, right? It depends upon what you're doing though. So there's a couple things, getting really cheap devices. If you have a small garage shop, hobby, you're doing things that don't really have tight tolerances to them. You can get by with these from the learning phase. But there are definitely things you need to know when you're getting a cheaper measuring device. So we have two concepts here, right? We have indicating and we have measuring. So measuring is knowing how big something is, right? This is 250 thousandths, this gauge block, okay? I can take my nice micrometer here and we're gonna crank this guy down. And this one is, I don't know if you can see it on the camera, but it is 250, on the dot. This micrometer is coming in dead on for my gauge block, which is a certified gauge block. So, we've got something pretty nice there. Now, that's measuring. Indicating is a relative position thing. So here's a great idea to relay that concept. Let's say that I am going to do something on the lathe and I want to have a mark this far from a feature. This far, whatever this object is. This could be some object of unknown size. And now we're talking about when we're getting into the less accurate areas. So I take my caliper and I'm going to go over the lathe and I blued up my part and it's spinning in the machine and I'm going to touch off the end and scribe a line, okay? I would never do that with my good calipers. I don't want to wear the tips down on them, et cetera, et cetera. Lots of reasons not to do that. But for a cheap junk caliper, it's not a bad way to go. And this one actually sits out on my bench all the time because it gets abused. And the reason it gets abused is it doesn't return to zero reliably. So this one is junk. When I first got it, it had a bunch of burrs inside. It was cheap. Quinn is the brand. I don't know where it comes from. But I bought it for that purpose. Just have something on the bench I could toss around to quickly make a comparison when I'm just checking things out. I want to transfer a distance, let's say, from a part on the lathe over to the reference part on the bench, whatever that might be. But it's only used for rough measurements. Cleaned it up, got the burrs out of there, and it repeats to zero most of the time now. But, oh, there we go. Yeah, we're off, we're on, and it just isn't reliable. So it's been relegated to junk use. Now these other two here, these are both cheaper ones. Both came from, I believe, Harbor Freight. And these are actually not bad for their repeatability. They both, the digital and the dial, both return to zero every single time, right? I do use them for measuring on devices, not just indicating relative distances like I would with this one. But I don't use them for anything near the final end when I'm getting down to actual size. That's when either the Mitutoyo comes in or my micrometers come in. Okay, but they're really good for taking off 50 thousandths off a thing, whatever it might be, and you just want to know when you're close. These do a good job. Okay, and of course then there's the Mitutoyo, which I trust, and I've compared it and these with my gauge blocks to see where there's some variance, and that was in the research of this video, so I just wanted to put this all together for you guys to see. Okay, so we've got our good devices down here and our cheap devices. So we came in at 250 with our good micrometer here. Let's go ahead and look at this one. All right, I'm going to dial it all the way down so it can get to 0. Okay. And you see we got a couple millionths that it's coming in. I'll just go ahead and put it at 0. Okay, there we go. We are zeroed. And there we go. This one is a little sensitive to how fast you click the ratcheting dial. So it's one of those, I don't know, idiosyncrasies of cheap devices. Okay, so we're a little bit over. Let's go ahead and measure our block here. Okay, and you can see we're measuring a little bit over. And that's that variance that was shown when I was zeroing it. So there's a little bit of variance in here, but you can see how small that is. We're into what, the millionths there? I'd have to double check. The glare is actually, you could probably see it better than me. So we're measuring 250, so not bad. So pretty good for a quick measurement. Now, the one thing I do want to show you though is the problem that you can get in cheaper devices. Even though it appears to measure accurately, one of the issues you can get is that these anvils may not be ground flat and parallel, but also may not be ground perpendicular with the movement of the micrometer. So that will throw in variance. It won't show up as often on thicker parts that are larger than the anvil. But measuring round items, you can definitely get a variance in there. And let's see if we can demonstrate that. I know this one has a little bit of variance in it. So if I measure just on the edge, there we go. We're getting 24,995. Okay, and if I go to measure the other edge here, I get 24,995. But if I measure the whole thing, I get my 25. And what that really says is that somewhere between these two anvils is a high spot, right? So when I measure with a larger block, something larger than the anvils, I am trapped between the two high spots. And those are what I zeroed out at, and that's where I get my relatively, accurate measurement on this. But if I were to measure something like a cylindrical object, okay, and I measured a little off center over here, all right, we're 24975. Let's see if we can get this one to show 24975. It's a little hard to do with a round object because I don't know where that bump is. Okay, so we got 2497. Let's see if we go right to the edge, 24975, and I don't know where that bump is, right? So, okay, there we go, 24965. So you see we're getting a considerable amount of variance when we put a round piece in there. So you just got to keep that in mind. And I do still use this if we're getting very close, because you can see, you can see it was a few tenths off is all it really was. So it's not bad. You can't get down to tenths level accuracy with it. But most of the time in the shop, at least our shop, we're a manual job shop, tenths don't happen. It's pretty rare when we get down that far. Okay, now we're going to go over and look at our calipers here. So when we're looking at our calipers, we have a couple things, right? Like I said, we want repeatability and we want accuracy. So let's go ahead and grab this digital one just because it's easier to see on the camera. Okay, so you can see we're zeroed. And we come back to 0. Every time on this guy. I don't have to re-zero this one. It just always comes back to 0 for me. So let's take a look at our 250 gauge block and see what it measures out as. Okay, now you can see we're measuring 249, so we're under actually. But look at this. There's a pivot. Oh, now we're 2505, and we're stuck on this pivot that is apparently right at the end here. Okay, and let me show you what causes that. So we're going to get a light, and we're going to shine some light through. And there we go. You can see there's a gap, but the tips meet. So what that means is, depending upon where you measure, now I'm pushing really tightly, and you can see it closed up at the back, but there's a gap in the middle, and it's closed up at the top again. So what that means is when we're measuring an object, something, again, of a larger size, and if we've zeroed off our largest dimension in here, we're going to get something close to the actual size. And even this one isn't coming up there. 250 if I put it here, but I'm getting 2490 here. And the reason for that is when I closed it and it was zeroed, it's zeroed at this tip, that high spot right there. So if I measure at that high spot, I get my 250. Whoop, there we go. But if I move it off of that, now I'm measuring low. So there's an example of where that can come in. Now, the other part that can cause problems is when you're measuring something that is round, where you only have tangential contact on here. So we'll see we're 2490 here, 2485 here, 2490, 2485, 2485. Let's see if we can get one on the end here. We had a 2490. There we go, 2490. So let's get different measurements based upon where you are because of that gap variance that occurs here. So let's go ahead and look at a couple of the other ones. Okay, so this one here, again, you can see that gap, and this one's even worse. Look, and I'm pressing very hard on the thumb wheel right now, very hard. All right, and that gap won't come up. There's right at the very edge. Let's see. At this back edge, I can see it. I'm not sure if it's coming through the camera. Right here, this very last little bit is where this is actually touching at. So again, the same thing. These are only used for when I get close. I don't worry about the last few thousandths when I'm using these. Now let's take a look at this one. Okay, this is the one where the dial doesn't repeat. Now if you notice here, that's a really good grind on those jaws, right? I'm putting zero pressure on the dial, and it's closed up. I'm going to show you my Mitutoyo the same way. So the Mitutoyo, let's make sure that's closed, there we go. Not a single little bit of light coming through the Mitutoyo. So you might think, oh, that's great, these are wonderful, they're as accurate as the Mitutoyo. No, not necessarily. The measurement device itself, right? This is unreliable. But the other part is, just because these are parallel, again, does not mean they are perpendicular to the linear motion of the caliper. So if these are off, you're going to get a different measurement than what you have in reality. So not bashing on these devices because they do have places in the shop. Again, just comparing rough sizes of something. I want to go to the stockpile and I want to find out, I've got random item A over here. Okay, it's that size. I'm going to go to my stockpile and just see what might be close to that size. Great for something like that. Again, marking things on the lathe when I want to put layout lines on bluing, really good for things like that. So having a cheap pair isn't necessarily a bad thing, just don't rely on them for your accuracy. If you can, go ahead and get one good micrometer or a set in the sizes you usually work at. And for most hobby people, a 0 to 1 inch or a 1 to 2 inch is probably going to cut it for most everybody, right? So get a good micrometer, get one good caliper, okay? Put them in the case when you are not using them. Put the case in your toolbox, okay? So keep that good. Same thing with the micrometer. Its case is in the box. It's got a larger case because this is part of a set. But every time this is done, it goes back in the case. Okay, same thing with this one. Goes back in the case every single time. Sits on the bench. Goes in my measurement drawer, but these do not have a case they go in. They came in a very cheap, it's a plastic box like this, but it wasn't a good one, so I just chucked it. And since they're not that accurate anyway, I just put them in there and use them for, again, that 90% when I'm taking things off. So I hope this comparison and a visual demonstration on some of the differences between a high quality measuring device and these cheap ones you can get. I hope that covers and explains a lot of the questions that have been asked over time. So if you've got any questions on any of these devices or some use cases or different ideas, I'd love to hear them. So just comment down below and we'll see what you guys think about having cheap measuring devices in the machine shop. As always, thank you for watching. I appreciate it, and I hope you have a wonderful day.